Today we want to talk about one of the solutions that service providers can build using Qwilt's Open Edge Cloud platform, and that is the Operator CDN solution. Service providers typically use an Operator CDN to distribute their own content to their consumers. This can be VOD content, it can be live, linear, or even cloud DVR content. And the idea is that with a CDN, they're able to bring the content a lot closer to the consumers and get economics in the distribution of the content, as well as quality of experience improvements to actually get TV-grade quality even though the content is traversing over the internet. So first, let's take a look at the components in Qwilt's solution that enable us to build an Operator CDN solution. The first component of this solution is QC. QC is our cloud-powered control plane for CDN. What we've done is leverage open source code and then build wrappers around it to actually create a fully blown control plane centrally managed from the cloud that doesn't require any controllers to be deployed inside the service provider network. QC then connects to the second part of the solution, which is Qwilt's QN nodes. QNs are essentially software caches that are deployed on top of commodity hardware and can actually serve as the delivery arm of the Operator CDN. QN nodes serve two purposes. The first is the edge tier nodes that serve as a reverse proxy between the users and the actual origin server that typically is hosted within the network. The second use case is as a mid-tier that is optional, and some operators choose to use it to serve as a proxy between the edge nodes and the origin server. And what this allows them to do is to reduce the load on the origin server in cases of multiple content pulls. So if we look at the entire architecture, we essentially see three tiers in a typical ISP network. We have the edge tier that is the one closest to the users. We have the optional mid-tier serving as the proxy to the origin server. And then we have the control tier, which is the QC encompassing layer for the entire control plane functions. The only software that actually has to be deployed inside the network are the QN nodes. The control plane sits entirely in the cloud and is hosted by Qwilt. The QN nodes can serve multiple types of content sources over the same hardware infrastructure. The first obviously being the service provider's own content on the various use cases that we mentioned before. Additionally, they can serve third-party content if an operator chooses to leverage them for that, and they would do that through the Open Caching API that QC also supports as part of Qwilt's Open Edge Cloud solution. This allows operators to maximize their hardware investment and essentially have a shared infrastructure to deliver all type of content that their consumers want, be it their own content or third-party content. Operators access this solution through QC, which gives them a single pane of glass control plane and a dashboard that they can use for provisioning and monitoring the entire solution. Let's take a look at some of the functions that QC provides. The first function is discovery. Essentially, this is the connectivity between QC and each and every QN node that's deployed in the network and the ongoing health monitoring of each of these QN nodes, which is something that is an important criteria in deciding where and how to route traffic to these QN nodes. The second function is control. Control enables operators to create delivery services that define how the CDN is going to actually distribute their content to the users. Under delivery service creation, operators can define things like host names, cache key calculation, URI signing scheme, as well as the transport protocols that is going to be used by this delivery service. Additionally, they can configure things like content invalidation, purging, as well as pre-positioning into individual QN nodes. The next and probably the most important function of a CDN is request routing. Request routing essentially controls how QC can distribute content to the individual QN nodes and make sure that the right QN node is the one that is being used to the relevant person that is consuming the content. Criteria used to decide where to distribute the content can be both geographic, i.e. the zones that a given consumer belongs to as it pertains to the QN nodes, but also health criteria, which is how busy, how loaded is a given QN node, and is it able to serve the content right now. Qwilt Solutions supports two methods for request routing, one being DNS with CNAME delegation, and the second being using HTTP redirect, typically using 302s to actually decide which QN node is going to be used for delivery of the content. Every delivery action in the CDN has to be logged. As many people say, if it's not logged, it's a hobby. In our solution, what we support is transaction logs that are being transferred from each and every QN node and collected by QC as a central aggregation of the logs. Operators can then access that information from within QC. An additional option is that QC can stream the log files into a third-party source that can either be hosted by the service provider or by an external entity if that is the operator's choosing. The fifth and final piece of the solution is analytics. This is a single pane of glass dashboard that operators can access via QC and basically gain complete visibility on how the CDN is performing, what is the amount of bandwidth that is being delivered, cache hit, and additional information as to the health of the overall solution in their network. Putting it all together, Qwilt created a very streamlined solution that operators can easily deploy and run in their network. We leverage an open source core that's been proven to deliver multi-terabits of traffic daily and basically ported it to the cloud, gaining all the benefits of being cloud hosted, primarily scalability and resilience of the solution. Qwilt solution supports a variety of network hierarchies, and we can tailor a solution to each operator's individual needs. The QN nodes themselves are multi-home, so they can serve any type of content if an operator chooses to do so, which ensures a future-proof solution for today's consumption need, as well as anything that's coming over the horizon, things like VR, 4K, and augmented reality, and basically use the same nodes to distribute and deliver all of them.